And when we talk about the ambiguous case, we're going to talk about the sine law again, just a little bit different. Overall, the definition of ambiguous is that it's open up to more than one interpretation. So in this case, there may be more than one correct answer. So the reason that this only really applies to the sine law is because the sine ratio is quite specific with its angles. For example, the sine of 60 is 0.8660254404. Or if you've taken exact values, it's a square root of 3/2. Sine of 120 is the exact same value. Now this works for any angle that you actually subtract from 180, which means if you're looking at 110, 180 subtracting 110 would be 70. 170 and 10, 140, 40. Well, all of those come out to be the exact same sine ratios. Not the same for the cosine, but just for sine. Next thing that we really need to be concerned about is how many degrees are in a triangle. So we're going to set up a few cases to help illustrate what this actually means. So in our first case, we're going to have one side that is going to be too short. So if we have triangle ABC, again, I'm just drawing any kind of generic triangle just to help illustrate and put in our values. It does not need to be drawn to scale because we don't know exactly what all of our measurements are. Side B is 25 centimeters, side A is 15 centimeters. So naturally, if we're looking at this, we'll be able to see that we have an angle and a side across from it, which means that we're going to have to use our sine ratio. Sine of 47 divided by 15. The only value that we can calculate would be angle B. And obviously, our side across from that one is 25. So we do our manipulation, we do our cross multiplications. So 15 multiplied by the sine of B equaling 25 multiplied by the sine of 47 divided by the 15 sine of B is 25 multiplied by the sine of 47 divided by 15. Taking the sine inverse, but when we type in the sine inverse at 25 multiplied by the sine of 47 divided by 15, obviously making sure that we're in actual degrees, we get an error. The main reason behind that is actually, as I've already stated, one side is too short. So in all reality, this is what this question is looking at. We have a 47-degree angle at angle A. We have a 25 centimeter side. And this is how it would actually look like. Because we don't have a complete triangle, by definition, we do not have a triangle. So meaning we don't actually have any triangles. Now, as an FYI, I do teach this my own kind of method. There are other ways that this ambiguous case can be taught. I teach it one way because it seems to make the most sense to students. as opposed to having to memorize a whole bunch of rules. You kind of follow one line of thought, and then you're all set. Right. Our second case is we're going to have a right angle. So we're going to do the exact same kind of information. Set up our triangle. Identify our information. A, B, and C. Angle A being 30. Side C is 10. In this case, yards. And we have 5 yards. So sine of 30 over 5 would equal the sine of C over 10. Do our manipulation. So our cross multiplication, 5 multiplied by sine of C. So we would have 5 sine C equaling 10 sine 30. Divide by the 5. Sine of C equals 10 sine 30 over 5. Sine inverse. And C. I just have to double check. Make sure. Yeah. C should come out as a 90-degree angle. I'm just going to type that in my calculator just to double check. Yeah, comes out as a 90-degree angle, which means we're actually working with a situation that looks more like this. So therefore, we can calculate a whole bunch more information. For example, we could use our Pythagorean theorem. That's our 90-degree angle. We can use a Pythagorean theorem to find out what this side is. Doesn't hurt to do it. Let's see, our 10 squared, b5 squared, adding our b squared, subtract the 25. So we have 75 equaling b squared. Square root of 75. Approximately 8.7. And you can take your 180, subtracting 30, subtract 90, will give us a 60-degree angle up here. So we have a right triangle. So there's not too many things that are uncertain or left to interpretation here. That comes on the back side here. So it comes with our third case. Do we have two triangles? I just want to see how far down I have. There we go. This is going to be the very focus of our understanding. So meaning we have to be able to set things up correctly first. Of course, draw your triangle. I do require you to draw a triangle because it's going to be the thing that's going to be the easiest for you. See, A, B, and C. B is 30 degrees. Side A is 20 centimeters. Side B is 15 centimeters. So meaning I'm going to set up my sine law. Sine 30 over 15 would equal the sine of A over 20. So I do my cross multiplication. I'll color code this one. Sorry, I just like doing my manipulation. Do my sine inverse. Make sure I do it to both sides. And angle A would then equal, let's see, sine inverse of 20 multiplied by the sine of 30 divided by 15. Divided by sine of 30 divided by 15. Angle A would then equal 41.8 degrees. So we can continue and solve more information. So that's 41.8. We can solve for angle C, because that's going to be 180, subtracting 30, subtracting the 41.8. So 180, subtracting 30, subtracting 41.8. Comes out as 108.2. And then further on, we can solve for this side. So let's see, I have this relationship. If I have all of this, could I use my cosine law? Yeah, I could use my cosine law even. But I know that the sine law is a little bit faster, so I'm going to stick with sine law. So sine of 30, 15. Notice how I am using a calculated value. Well, that's simply for the reason that that's the only thing I can use to help calculate. Oh. Stop recording, good. Cross multiplication, C multiplied by the sine of 30, 15 multiplied by the sine of 108.2. Notice how I will not have to use any sine inverse because I don't have to solve for an angle here. I'm solving for a side length. Now, of course, keeping in mind that this is going to be a rounded value because I rounded that 41.8, therefore the 108.2 is rounded, which means my value may not be exactly correct. Oh, 28, sorry, 0.5. And unit centimeters. So we have a 28.5 across from the longest angle, 41.8 from the middle, and 30 from the smallest side. So where does this ambiguous case come into? Well, it comes into here. Because we did the sine law, and as we had talked about at the very beginning, the sine of 60 is the same thing as the sine of 120. Well, that's the exact same kind of information as the sine of 41.8 is going to be the exact same as what? Sine of 138.2. Double check. Yeah. So what we need to do is we need to take this first calculated value. Yes, we solve for the rest of our information in this triangle. What we need to do is we need to take this angle and subtract that first calculated angle from 180. And then we substitute the new angle into the triangle. So that triangle that we had created, yes, I know that this will not be drawn to scale, but we can still have angle A, angle B, angle C. Angle B is still 30. Side B is still 15. Side A is still 20. But when I substitute the new angles in triangle, where I wrote that 41.8, I'm instead going to write 138.2. Because I don't know whether this angle is actually 41.8 or whether it's 138.2. The sine ratios would be the exact same. So I really don't know whether this angle is one or the other. So my next step is to check whether the new triangle is viable, which essentially means, so let's see, this is our second step. Third step just means, well, do our degrees actually work? If I take 180, subtract the 30, subtract the 138.2, get 11.8. You can have an 11.8 degree triangle. Or is our angle, sorry. And last step I ask is to solve the triangle, which means solve for this unknown side. Let's see, so we can still use our sine law again, because it uses, or it's the kind of the shortest one to do. Cosine law, absolutely you can do. I just have to take 15 squared, add 20 squared, subtracting 2 times 15 times 20 multiplied by the cosine of 11.8. Should come out to be the exact same thing. Side C. So C multiplied by the sine of 30 would equal 15 multiplied by the sine of 11.8 divided by the sine of 30. So 15 sine 11.8 divided by the sine of 30. Oh, make sure I end off my brackets. 6.1. And this one also makes sense. Our smallest angle is across from our smallest side. Largest angle, largest side. Middle angle, middle side. So obviously, this actual triangle would be very construed. It would be very different. For wanting to draw it a little more to scale, it'd probably look a little bit more like this. But overall, what we need to identify is, yeah, there's two triangles possible. So we're going to do some more exercise. We'll have one more case and then one example. So we're going to check, again, is there more than one triangle possible? So we draw a triangle. If you can get away without drawing the triangle, you are welcome to it, but it's going to be very difficult to try and organize your information. I absolutely recommend you to draw a triangle because it doesn't hurt to draw an extra picture. Having a visual of your information should never make you lose any marks unless you put your information in correctly. So sine of 65 over 20 sine of C over 15, cross multiply. Twenty sine C equals 15 sine 65. Divided by the 20. And sine inverse. So our sine inverse, 15 sine 65 over 20. I'm getting 42.8. So this angle would be 42.8. Of course, I'm going to keep on solving every single bit of information that I can. I'm going to solve for this angle by taking my 180, subtracting my other two unknown, or two known sides, sorry. And I can solve for my last side. Where is that? 65. Notice how I still keep on going back to my first actual known information. Do my cross multiplication. Do my manipulation. So 20 sine of 72.2 divided by the sine 65. B side 21.0 meters. Might not look it, but yeah, our largest angle is across from our largest side. So this one's for sure good. But then we have to follow our steps that are just above here. That calculated angle is that first calculated angle, which means we're looking at this one. Subtracted from 180. Our second step is plug it into that same identical spot in the triangle. So our information is still going to be the same. This angle is still 65. This side is still 20. This side is 15. It's just all of our other calculated values are no longer the same. So instead of writing 48.2 in this bottom right corner, I write 137.2. My next step is to check if the new triangle is viable, which means I take my 180, subtract the 65, subtract the 137.2, and I get negative 22.2. Well, that for sure makes no sense for an angle. You can't have a negative degree angle in a triangle. It's just not possible. If you have a Cartesian plane, okay, but not for a triangle. You can't do it. A triangle adds up to be 180 degrees, which means all three angles have to actually have a sum of 180. You can't have a negative degree, which means this triangle is the only one possible. We only have one triangle possible. And this is how it is. So if we calculate this out and we get a negative angle in here, yeah, it doesn't work. This is also why I always encourage you to round things to the nearest tenth, because there may be a case where the angle is really small, but the triangle would still be possible. Okay, nice example. Two students, Eileen and Tony, are standing by a vertical flagpole. From Eileen's position, she makes a 30-degree angle and with the ground, and she is 20 meters away from the top of the flagpole. From Tony's position, he makes a 50-degree angle with the ground. How far away from the top of the flagpole is Tony? And how far apart are Eileen and Tony? So let's check it out. So we have Eileen and Tony are standing by a vertical flagpole. So we have a flagpole, straight vertical. Says Eileen is 20 meters away. So on the ground, we can say that from here to here is 20 meters, and she's making a 30-degree angle with the ground. Tony, though, is making a 50-degree angle with the ground. Oh, sorry, at 20 away from the top of the flagpole. Sorry, that's the wrong spot. Let's put it in the right spot. So let's identify a few bits of information. For example, on a straight line, that's going to be 180, which means 180 subtracting the 50 would be 130 degrees. Because of that, we can also state that 180 subtracting 30 subtracting 130 is 20 degrees. So that top angle is 20. And we have 20 there. So we can have a whole bunch of information. Now what we really need here is we need to know how far away from the top of the flagpole is Tony. So the question is asking, oh, sorry, maybe should I identify that Tony is right there. We need to know, what is that? Well, we have all the information that we actually need. We have an angle and a side across from it. We have an angle, and we're trying to find out the side across from it. So sine of 30 over x would equal the sine of 30, 130 over 20. Now, of course, there's probably more than one way of calculating. For example, it does say it's a vertical flagpole, which means that this entire angle here would have to be 60 because this would make it 90. We could do a whole bunch of calculations there, find out this one, do some more manipulation, calculations. It's possible. This one is just going to be the fastest. So I do our cross multiplication. X multiplied by the sine of 130 would equal 20 multiplied by the sine of 30. Divide by the sine of 130. And Tony is how far away from the flagpole? Oh, write down exactly what I'm going to be typing in my calculator. Multiplied by the sine of 30 divided by the sine of 130. Tony 13.1 meters away from the top of the flagpole. So if he's 13.1 away from the flagpole, and Eileen is, oh, we're gonna have to do some more work. Let's see, how far apart are Eileen and Tony? So I guess the next part of the question is asking, what is that? So I guess we're gonna have to use our sine law again. Except the only difference is we're gonna use the sine of 20. Sine of 20 over y would equal the sine of 130 over 20. Do our manipulation by our cross multiplication. Sine 130, 20, sine 20, divided by sine 130. Make sure I'm thinking about my calculator correctly. So 20 sine 20 divided by the sine of 130. So they are 8.9 meters apart. Fantastic. So they're 8.9. So if Tony's 13.1 away and Eileen is 8.9 further than Tony, Eileen would have to be 22 meters away from the flagpole. Fantastic. But we're not done. Because it doesn't say necessarily that they're on the same side of the flagpole. At the same time, this would be the minimum distance, because if Tony's a little bit off on the side, we could be dealing with some things like that. But this would be the minimum distance that would be here. At the same time, there's another opportunity. Flagpole is vertical. Eileen could be on one side. And Tony could be on the other. So we're going to have to solve both situations. This is that interpretation. It's left up to interpretation. We need to identify the information we have so that we can actually do things properly. So let's do some information. Let's do some calculations. Let's see. Flagpole is vertical. We know that that's going to be 90 and 90. We have a large triangle here. Calculating that top angle would just be taking 180, subtracting 30, and subtracting 50, making it 100 degrees. And then we can keep on going. So if we want to find out how far away from the top of the flagpole is Tony. So we want to find out, what is that? Well, the great thing is, we have an angle and a side across from it. Angle, and we're trying to calculate what is the side across from it. Meaning, I have the sine of 50 over 20 is going to equal the sine of 30 over x. I know that I said when we did our sine law, you can invert these, so you could have 20 over sine of 50 and x over sine 30. They both work out. Do the cross multiplication. Oh, that should be 50. Sorry. Uh, 20 sine 30. Divide both sides by the sine of 50. So if they're on opposite sides, if Tony's on the other side, 20 multiplied by the sine of 30 divided by the sine of 50, Tony could potentially be, oh, fantastic. It's also 13.1 meters away. top, not Tom. But you can also tell that the distance between Eileen and Tony is a much larger value. Now, I just want to do a little bit of an analysis here. We can see here that we have the sine of 50 over 20 equaling the sine of 30 over x. When we had done it over here, we had sine of 30 over x equaling sine of 130 over 20. This is still our ambiguous case. And the reason that we have the exact same value is because the sine of 130 and the sine of 50 are the exact same thing. That's why they come out to be the exact same value. So if we want to solve for y, this one is not going to be the same because the sine of 20 is not going to be the same as 100. The sine of 20 is the same as a sine of 160. That should be correct. Sine 50 over 20, fantastic. Do our cross multiplication. Do our manipulation. So 20 multiplied by the sine of 100 divided by the sine of 50. So 20 multiplied by the sine of 100 divided by the sine of 50. I get 25.7. The units would be meters. So they would be 25.7 meters apart if they were on opposite sides of this flagpole. So instead of the 8.9, they're quite a bit further apart. Again, the ambiguous case deals with an uncertainty. It deals with something that's left up to some interpretation. In this case, we need to interpret, are they on the same side or on the opposite sides? I would have the expectation that you would solve for both sides. Okay. Go have fun.